Hello everyone. Today we are going to cover the discovery of electron. Okay. So many scientists came, they describe the structure of atom on the basis of like internal particles, like we have subatomic particles. So many experiment was done by different scientists also. So most of the scientists they contributed differently in discovery of subatomic particles, and the contribution started from the Michael Faraday only. Okay, so Michael Faraday, see somewhere it is like 1830, somewhere it is 1832. So again the time was not, they started experiment on 1830 and they completed on 1832 like this. So somewhere this time is not proper is given. Okay. So he passed electricity through the solution. Okay. That solution contain ions, beta, ions like positive and negative ions, right? And negative and positive ions are formed due to the loss and gain of electron, as we know already. And okay, and called the phenomenon as electrolysis. So the phenomenon where electricity is passed through the solution, okay, containing iron. So like somewhere deposition of material takes place and somewhere gases are being released. So as we discussed yesterday also, like suppose if we are performing electrolysis of NaCl, beta, NaCl, sodium chloride. Okay, so NaCl on molten condition will present in Na positive form and Cl negative form. So that Na positive is going to travel toward the negatively charged electrode. Okay, and which is called as cathode. So where sodium will gain electron, but that negatively charged chlorine ion will going to travel toward the positively charged electrode, and positively charged electrode is called as what? Anode. Okay, so at anode always oxidation reaction takes place because chlorine negative ion is going to lose electron and will form chlorine gas. Okay, so at anode chlorine gas is going to release, and on cathode sodium metal is going to deposit. Is it? So during this process, okay, exchange of electron takes place, beta. Exchange of electron means some species will going to gain electron and other species will going to accept electron or lose electron. One is going to gain, other is going to lose. Okay, so this process is called as beta electrolysis. It's called as what? Electrolysis. And in 12th class, we have one whole chapter on electrolysis. He observed that charged particles, see, charged particles means they may be positive or they may be negative, migrate toward the opposite charged particles. As we discussed already, that sodium is positively charged ion, so it is going to travel toward the negatively charged electron. Chlorine is negatively charged, so it is going to travel toward the positively charged electron. Okay, so they like why? Because we know already opposite particles they attract each other, and same like charged particles they repel each other. During this process the accumulation, okay, on the electrode or escape out the gas at electrode takes place. So yes, we already gone through that. At cathode sodium is going to accumulate or going to deposit, and on anode so chlorine gas is going to release. Okay, so here he confirmed that it was not confirmed, he was just predicted that matter which are made up of positively and negatively charged particle. Okay, but it was not confirmed that it is electron or proton like this. Okay, but the discovery started from Michael Faraday. But later on in 1897, J.J. Thomson performed the experiment called cathode ray discharge tube. We are going to discuss here that in detail. Okay, and he came to know that like charge particles which are, sorry, negatively charged particles which are revolving around the nucleus. Okay, and he confirmed that particles and named as electron. Okay, so it was confirmed by J. Thomson. Okay, it was confirmed by J.J. Thomson in 1897. So experimental setup that we have here, it consists of the long cylindrical tube, as you can see here. This is the long cylindrical tube. Okay, sealed both the end and fitted with two metal electrode here. So here we have a negatively charged electrode. Why it is negative? Because it is connected with negative terminal of battery, and other one it is positive one. Why? Because it is connected with positive terminal of the battery. Okay, the electrode are connected to the source of high voltage electric current. See, high voltage of electric current we have to pass, then it is going to like show the cathode ray there. It is not possible on the low voltage current. The tube is connected to the vacuum pump. See why vacuum pump? Because it is again possible at a very, very low temperature. He performed experiment on different atmospheric pressure like 1 atm also, but experiment was not done. But when he decreased the pressure inside the tube, okay, approximate vacuum. It's not perfect vacuum because particles was there, okay, but very less. That's why it is called as like evacuated tube. Okay, only few particles are not, so it is not perfect vacuum inside it. To increase or decrease the pressure, why we have like kept that pump here, we can accordingly increase or decrease the pressure inside the tube. The discharge tube is filled with air. So initially it was filled with air, and then air is being evacuated so that very low pressure present inside the tube. Okay, so this is nothing but the arrangement of the setup. Okay, now we are going to discuss about the experiment. He passed electricity at a high voltage through the gas at a very low pressure. See, pressure was very low beta because gas was removed with the help of vacuum pump taken to the discharge tube. Okay, now we are going to understand observation. First point here we have, when the voltage is high, see voltage is high and pressure is 1 atm pressure beta. So he performed like experiment on different pressure. So first he performed experiment at 1 atm. So no electricity could flow through the air. Okay, there was no electricity flowing through the air. Okay, then second point, then the voltage is very high again, but pressure is reduced to 1 mmHg. It is millimeter of mercury beta. Okay, it is called as mmHg. And we have that sphygmomanometer in order to where we are like getting the pressure mmHg. Electricity started flowing. See, at that particular lower temperature, electricity start flowing through the tube. Okay, light was emitted inside the tube. Okay, and you know that ray, it is appears over here like this. Okay, and it starts lightening up. So it started lightening up. It shows that electricity was flowing from one end to other end, from cathode to anode, because at a negative electrode particles are getting charged, and particles are what? They are electron. So electrons are getting charged, very high charge, and in order to discharge that high charge, and we know that electricity always flows from higher potential to lower potential, right? Everyone, higher potential to lower potential. Yeah, likewise here, electrons at the cathode becomes very high charge, and they started moving in a straight line from cathode towards the anode, from cathode to anode. So that time, that path was appearing in the form of light, in the form of light. When the voltage is high and pressure is reduced to 0.001 mmHg. So again, we have reduced the pressure because we have the pump. So accordingly, as per our wish, we can reduce the pressure inside the tube. Okay. Wall of the discharge tube at opposite, cathode started glowing, okay, with greenish light called fluorescence. Okay. So see here, particles, they are moving in this particular side, and when they are colliding here, okay, when they are colliding, so greenish color light is appearing over here on opposite of the cathode, means at anode beta, because they are colliding, particles are colliding. Suppose here we have the anode and here particles are colliding. So due to collision, like light, they started lightening up there. Okay, so this is nothing but that color appears green glow. The fluorescent means we can say it was shining. The fluorescent is due to the bombardment. Bombardment means colliding of the particles of the wall of the tube by the ray emitted from the cathode. So these cathode are nothing but electrons. Okay, that rays which is formed due to the flow of charge through electron, and when they are colliding on that particular wall, so they lighted up in a green and they shows green glow. Okay, so that particular light which has started from the cathode and traveling toward the anode, hence it is called as cathode ray. Okay, it is called as cathode ray, hence the experiment is also called as cathode ray discharge tube. Okay, there are known as cathode ray. Why? Because it started from the cathode, from negative electrode inside the evacuated tube. They consist of negatively charged particles called electron. Okay, so see why they are considered as electron, because they are moving toward the positively charged electrode. And we know positively charged electrode, if they are attracted toward the positive charged electrode, that means they must be negatively charged particles. Okay, and it was confirmed by J.J Thomson in 1987 that matter or atoms, they contain negatively charged particles, and he named as electron. Okay, so now we are going to discuss about characteristics of electrons. The charge on electron we have already discussed that day. It is 1.673 into 10 to the power minus 19 of Coulomb. Okay, and it is found like very small negative charge carried by the particle. Okay, so it is taken as negatively charged. Okay, the magnitude of charge on electron is considered as beta negative. The absolute mass of electron, see one more thing, you have to remember the mass also. So it is 9.1 into 10 to the power minus 31 kg. Okay, or if you want to calculate in grams, so it will be 9.1 into 10 to the power minus 28 kg. Okay, in gram, but in gram it is 10 to the power minus 31 kg. So this is all about the discovery of electron. So I want everyone have to just go through it once and let me know if any doubt you have.